Welcome to our tech talk on Retrieval-Augmented Generation. Today we'll dive into the RAG system we have developed at Tarka Labs known as Vidura. We'll examine the limitations of traditional knowledge retrieval systems and demonstrate how Vidura bridges these gaps by integrating advanced search capabilities with knowledge databases to provide precise and context-aware answers. Our process involves document chunking, vectorization, and sophisticated retrieval techniques to transform queries into actionable insights. Join me as we explore the intricacies of Vidura from the initial vectorization pipeline to the final augmented generation of responses, ensuring our system delivers accurate and efficient knowledge retrieval. Let's get started. First, head over to Vidura and enter the passkey to begin. For the passkey, please contact us at hello@tarkalabs.com. All links are in the description below. Once inside, you can post a question and receive a context accurate answer complete with references that include page numbers and source documents for easy traceability. Following this, we'll take a detailed walkthrough of the process, showcasing the techniques we use to build this robust system.
So here, based on that, we have pre-operation checks for the machine include reading machine safety warning. So it also got the 5 by 8 inches, 5 to 8 inches, 20 psi, and all of these stuff also correct. So if we go here, we have non-foaming oil, this, and cold water supply, this particular pressure, and all of that. So, and it also adds the reference that okay, this is the document that I am looking into, manual.hotc.pdf, and you are getting it, the information in the are in these pages. So if you check here, this is a 10 number page where this has been extracted from. Any other, if there are, one second, what are the, let's say, setup procedures? So we would expect that okay, this answer will be derived. I'll move on to even other scenarios. There were a lot of scenarios in the PDF where we had to face a lot of technical challenges. So these are the straightforward ones where the texts are being derived. So yeah, based on this question, this particular paragraph was extracted, and page it's saying okay, page number 10 it has it, and all these points are basically there are 6 points here, so these are all the exact answers. So the advantage of this is when we ask an LLM a question, it is difficult to pinpoint the actual source of the answer since it is more of a generative model. Here we have kind of grounded the answer to a PDF so that the technician who is actually working on this system would be sure and the answer is trustworthy, that it is actually coming from the document and the manual itself and not kind of hallucinating or talking about redundant things or just talking about plain wrong things. So that is an advantage we see here, especially in this particular system. So those are simple text-based questions mostly. So right now we'll just quickly move on to a table-based answer. So we have this table where we are mentioning, okay, these are the technical specifications for these particular models. So if I just, you can, it's just not a question answer scenario. You can also say something like summarize the technical specification. So here, ideally, we would want Vidura to go through this entire table and kind of summarize all the stats over here and then generate the answer. It did not somehow get it right. Let's ask what. So there are some challenges still that we are facing. There's a lot of document chunking and making sure that the chatbot itself is deterministic. So ideally here we were expecting that that it went ahead and summarized the entire table itself. So which is why we just asked for model 1724 so that we can be specific. So here it derived that okay 3.9 2230. So we see 3.9 2230, and then based on whatever columns it understood what are basically the characteristics, the specifications of this particular model. So so on and so forth. It can actually go ahead and answer based on tables as well. So concept, I'll just go briefly into the concepts and then we can see if there are any questions. But essentially, the concepts here are this is called as collections because we can have multiple documents in these collections. So even if you have multiple manuals or multiple other documents related to this pressure washer, we would want to add this in this particular collection itself. And then you can ask questions which would span across all the PDFs. So you're kind of merging all the PDFs and then you're asking a question, then you can essentially ask the question across all the PDFs. Cool. So I think that is what I had on the demo front. We'll just move on to a quick concepts based. I mean, just looking into the concepts of how we build this. Even before that, are there any questions or anything we would want to reiterate?
Hey, I have one question. Like you talked about PDF, right?
Yes.
So, is there a limit on the volume of data that this tool can take? Meaning, how much of data can it process? Like, if the PDF is too large, or if I fed a lot of PDFs, what is the limit to it?
So we haven't tested out the as an higher limit on this, but technically there should not be a limit. I'll come to why exactly, but what we do is we process the PDFs into chunks. So
Okay.
technically we can have as many chunks as we can. So which means we can have as many as PDFs we can. But there will be technical challenge there as well. So suppose if you have a lot of 10,000 PDFs in which there are 100 PDFs that have contradictory statements. If you ask a question, it is difficult to understand what would be the ground truth for the LLM, as in for Vidura to answer. If you can
Correct.
see, okay, there are 100 contradictory statements in those documents. So apart from those technical challenges, there is no limit on the total number of documents at least in the collection.
Okay,
I
got it.
think it's more of we'll end up using more resources, Mahesh, right? But it won't
Right,
be
right.
that it's not doable as such. Again, right, we
Yeah.
might have to handle the whole scale-based things in that, as Archit mentioned. But I think that thing which Archit mentioned is more important. If you do not have a single source of truth, or
Mm,
if whatever documents you're providing are not providing you the right info, then it becomes difficult. Because even if in this one, right, we pick multiple assets and each asset is one silo. So technically, you have to say, because kind of the questions which Archit was asking, right? Let's say, what are the technical specifications for model 1724? This model 1724 could be in all of the assets which are available. Now, if you
right,
have
right.
multiple assets, then you'll have to either pinpoint, or maybe the bot will start asking you subsequent questions saying, okay, what asset you're talking about, and those kind of things, right? But the other thing could be that you start, because if you look at the thing, he selected manual hot C1745 DES at the beginning, right? So this is
Mm,
saying that, okay, it can have one or multiple documents related to this asset, but just answer on from these itself, right? Because if you open it up to the whole thing, then getting a
yeah.
specific answer becomes a little difficult.
Right, right. Got it, got it. And are you using any tools like LangChain or something for this one?
So, let's just talk about the chunking piece. I think that will give some.
Okay, okay. Fine.
Hey, Dinesh, you have.
Yeah, I have this question. Like in the PDFs, you also get a lot of images, right? Some explanatory images and all. But I'm sure like where the interface that you work, it cannot provide you those informations, right? Is there a way that in the future, if this can be integrated with some external links or something, or how?
That's what Arul also wanted to do. So there are two types of images normally. One is an image which has some text written. I don't know if this doesn't make a lot of sense, right? But there are some images where you say that, okay, this is something you should change if something goes bad or something like that, right? Or maybe a name around that. Now those kind of images are still something we could make sense of, but overall, right, when you're scanning this, so we are using computer vision to use this, but even then it doesn't, we cannot make sense out of an image. So what we were trying to look at, and also there are some places where you have this whole diagram number and things written at the bottom of the image, right? Saying, okay, this is image 3.1 and
Right.
this is the name of the image or something, right? Now, what we were thinking was maybe if we extract out that image as it is and then show it. That was like one thing we are considering. That's something we do not support right now. Or the other thing we were even considering was, even if we don't do that, maybe just show the page, because even if you have, let's say, 50 manuals you have to look at, and most of these manuals are something we cannot search on. I think they're image based PDFs, so you cannot directly go in and search on these manuals as well. So the idea we had was, maybe if we show that if the whole screenshot of the
Mm.
page with the image, I think that's also something which will help the technician who is working on that. But right now, reading the images is something which we do not support.
Right, right. Yeah, at least as you rightly said, a pointer to the specific page or the screenshot of that image or something, that will be very helpful.
Correct. Even now, we are showing the page number of where we are getting this manual from. But the initial plan was that we wanted to link it to the page. Maybe host it on some S3 or something. You click on that, and then it takes you to that particular location. But given that we do not have all these manuals hosted, so we are showing the number, like the page number, and from where we are getting this info. But yeah, moving forward, if we have all this hosted somewhere, right, maybe on some website or something, then we can just put a link to that, right? So that could be part of the metadata. You click on that link, it moves over to that page and opens things up.
Right, right. Sure. Yeah. Thank you.
Cool. So yeah, we'll just go through. Are there any other questions, or we can move on? All right. Yeah. So traditionally, when we pose a question to Chat GPT or any other LLM, you get a response based on the query. So this is as simple as you ask a question, you get a response. There's no control over how the answer is being generated, and there's no control over where the data is being derived from. So what we would want as a use case was that, okay, I have a set of documents that I would want to inject into the LLM such a way such that if when you ask a question, the actual answer should be always derived from the documents that I'm presenting, the knowledge base basically that I have set up. So how do we do that is we'll come back to step by step on each of these pieces. But how we do that is when a user asks a question, you do a search on a database which has all the PDFs in it, and then whatever relevant passages from the document, which we'll be calling as chunks, basically the knowledge that is retrieved from the database, you pass it to the LLM to actually answer it. So when I asked the question, what are the pre-operation checks? We would want Vidura to essentially scan the document for relevant passages from the document and inject those relevant passages into OpenAI's chat GPT or whatever model that you will be using, and ask the LLM to answer only based on whatever the retrieved passages or retrieved knowledge that we have taken out from the DB itself. So this is kind of the simple flow on how we have essentially built Vidura. Just going by step on how we set up this entire thing was, so the PDF that we have, the first step is always the document chunking piece, where each logical section of the PDF or the document or whatever docx presentation or whatever, all of these should be chunked, divided into logical sections of the data. So when we are talking about environments, the only it should talk about environments in this particular chunk only. Then if we are talking about configuring environments, there should be a cohesive logical unit separation between those. There should not, I mean, one single chunk should not talk about two logically different things. That is kind of the uh, aim that we have here. This is a notoriously difficult piece that needs to be done for all the documents. This is the document chunking quality is directly proportional to the answer quality that we have seen. I mean, completely directly proportional. The better the chunking, the better the answers. It is as simple as that. So yeah, this is the first step essentially to get the chunks out from the document. Now there's a process called vectorization. I'll come to why we have to vectorize, but essentially all these document chunks, one of these chunk, and so there are two chunks here. These two chunks will create two vectors here. So we have an OpenAI embedding model, so you pass in the document chunk, which is basically a passage or a paragraph or whatever that logical piece of text is. You get the vector out from the embedding model, which we are calling. You can either call it as a vector or an embedding, which is basically an array of floats, as array of integers mostly. At least for us, we could say that okay, some length of 1500 array of integers is what I am thinking of. So one document chunk is mapped to one vector in this way. So vectorization is the second step where we, after chunking, you convert it to vectors. So if we have 3600 chunks, we'll have 3600 vectors over here. So all of these data source chunks we convert to vectors and then we store it in the vector DB itself. We index it into the vector DB. Why? So that when we ask questions, we can actually retrieve it. So this is the piece where we actually use the vectors. We use the vector search method to find relevant texts from the database and which will be then used to actually generate the answer. So we have all the data source chunks, convert to vector, and then store it into the database. This is kind of a simple pipeline where we have multiple data sources, multiple PDFs. We load the docs in memory or however you want to do that, and you chunk it. So if we have 30 PDFs, you can have 100 chunks per PDF. That is, however, 30,000 or whatever number of chunks that we have, and then we convert it into the embeddings, then we store it into the database. This embeddings, converting to embeddings that we called as vectorization, that is again, we are dependent on OpenAI itself. They have an embedding model that we call as an API. We pass it to we pass it the text and we get the vector out. And then we store in the vector DB, which is called Quadrant. We are using Quadrant as a database in the backend. So yeah, this is kind of the simple pipeline that we have. Moving on to retrieval. So retrieval, what is there any question?
Hey, sorry, I just wanted to do a time check. I think we are at 12. So, Constantly, how much? Because this can
No,
go on for some
no,
time. So,
there's only three sides. I'll just talk about the end part.
oh, okay. Yeah.
Yeah. So we ask a question, what are the pre-operation checks, which is the query. We convert it into a vector, and then we search it across the database, do a vector search. So when we do a vector search for this particular question, we are getting basically the relevant answers from the document itself. So you do a top K on the chunks. So this is one chunk that was returned for this particular query. So this is the retrieval part of it. Then we have the augmented generation part of it, where whatever retrieved knowledge we had, we pass it to the LLM. We prompt it in a way such that we say that, okay, this is the user query, this is the retrieved knowledge, create the answer, generate the answer only with the retrieved knowledge. So the response is something like, okay, this is the response. So this knowledge is being used to generate this answer by the OpenAI LLM. So that is augmented. So you're augmenting the answer generation with some ground truth source of data from our documents. So yeah, this is kind of the full circle we have come. Query, You convert the question into a vector, you do a vector search, you get the knowledge out, pass it to the LLM, and get the answer. So this concept, and if you want to search online, is essentially retrieval augmented generation (RAG). There are a lot of pipelines. I think we can just kind of take out, and it'll run out of the box. But there are specific challenges based on the domain you will be operating in, such as for EM360, we had a set of problems. For maybe if you want to do this on medical, we'll have a set of other problems that we would want to focus on. So mostly, yeah, this is kind of the vanilla RAG pipeline that we are looking at. So yeah, any questions? I think yeah, mostly yeah, done with it. Are there any questions on this? Yeah.
So we never needed to train any model or anything like that. We just needed to stitch the different like embedding models and LLM models and generate the pipeline, right? We never needed to train any model based on any of our custom data or anything like that.
No, no, we would need not do that, at least at this point of time. So we are just using OpenAI APIs to actually get this up and running. But ideally, we would want, as we go down the lane of 10,000 documents or having multiple question answer scenarios with multiple users, we would want to fine tune a model with our data such that it is easier on the wallet. So there's a lot of costs attached to this entire pipeline, especially the OpenAI pieces. So that is the way we essentially go about it.
And I had
So,
another, sorry,
yeah, so go on.
should you should go ahead.
No, no, I just had a separate thing on fine tuning. So there's one use case actually, which where fine tuning is the way ahead on the whole text to SQL piece, which I mentioned, right? So right now we are using this OpenAI APIs to get all the knowledge base, but the problem is that we will have to build our own knowledge base, which will kind of become a moat in the end, right? Because right now we are doing a lot of this prompt tuning, where we prompt tune it and then send all of this data within tokens, right? And say that okay, this is what it is, and we keep updating the prompts as and when we figure out new things. But the problem with that is that the size of prompt is increasing. So one is that the cost is increasing on for each call. The second is that we cannot go beyond a certain number, right? So let's say if we really want to build some actual knowledge base, so I think that's the next step that we have for now, going over to fine tuning. But for this one, we did not feel a need of fine tuning actually, because the vector search actually helps us doing that. But again, the bigger problem in this piece is not really the fine tuning, but the whole chunking. So there are a lot of constraints that we figured out, because chunking could be as simple as just chunk it based on sentences, paragraphs, pages, and this thing. But still, you will see that there are documents which are not falling in this purview, right? So there could be things, let's say there are tables across multiple pages. How will you chunk that? Will you chunk it at a page level, or will you figure out when is the table ending? And if that, then how do you make sure that it works for all of these, right? So I think these are the kind of major problems that we are facing on this Vidura. For normal questions, as Achit was saying, right, it works pretty well. But once you get into these kind of nuances, I think one of the problem was that the table, we were using a vision model, but the table that we had, the thickness of the borders was less. And that's the reason the model was not even able to figure out whether that's the line of the table. So like, and these are like problems which we face across different documents.
Yeah, that's where I was coming at the second problem actually. Like this prompt based querying, right, leads to multiple problems like query prompt injection and all of those, right? And other
Correct.
stuff is right. Like suppose this documents needs to be categorized based on access level and all, right?
Correct.
That maybe right now for your use case it's not categorized. Everything might be the open for everyone who is querying. But suppose a particular person has access to particular documents, particular person will be having access to particular document, and then you need to query based on those buckets actually. Then what would be the
That we could still do, right? Because at the end of the day, I'm hoping that from a single document they would not want to have access level control. But right now, even with quadrant, we do have metadata involved with that, and that's the way we are showing the page number and things. So I
Hmm.
think if we have to go to access level, it has to be beyond the vector thing, right?
Hmm.
So we'll have to still vectorize them. we'll have to still store them as vectors and things, and then maybe during the application layer or something, have an access layer on top of that, right?
Hmm.
So I don't think this process will really change even if you want to have access thing. I think the other major challenge would be that, say, if these models keep updating as well, right? Because right now they're also not in a very stable thing. So we saw that at times that this Monday things are working, 3 days later they just stop working, and then we have to compute all of these, right? That's another cost, right? Because if right now I don't think we have a way to say that I want to just do a part of this again, or I want to delete something.
Hmm.
So we are recomputing a lot of these things. So there are a lot of optimizations that we need to do, and we are also in this whole learning phase. But yeah, but this has been giving some good results actually, right? Because I think getting to 90% is still doable. Beyond that is what is the challenge. Or if you look at any corner cases on things, but I'm sure every PDF has some corner cases. So that's the place we are in.
Good, good.
Yeah, I think that was useful.
Wait.
Well, thanks,
Thanks,
Ajay.
Arvind. Thanks, Ajit.
Thanks very much, guys.
Sure. Sure. Thanks, folks. We'll take your leave.